Asynchronous programming is like having a single nurse tending to 10 patients. You can't stay with one while others are still needing your attention. So we have to juggle between different patients. For a program that needs to run linearly, where one task needs to complete before another task can happen, then synchronous programming is perfectly fitted for that. But there are some kind of program where some task takes a long time to complete. And in that kind of scenario, you don't want to rely on linear code execution. So you want to offload some of those long running tasks to the background. And this is where asynchronous programming shines. So while the program is waiting for the long running task to complete, it moves on to other tasks. And then when that is complete, it gets signaled and then it continues with it. So an example of a long running task that you might want to use a synchronous code execution for is calling a third-party API. Now, you don't have power over how long it's going to take for that API to return the response. So, and you don't want your program to stand waiting for the response to come back. So what do? You move on to a different task while waiting for the API to return the response. Another prime example is calling the DB to get data. The DB might return the data a little bit late, maybe due to latency or network issues. And in that case, you also don't want the entire program to stand still until the data is returned. So you offload that also to the background, handling it asynchronously while you move on to other tasks. In my next video, I'll be talking about multi-threading, which is another very powerful concept when it comes to concurrency. See you in my next video.